Let's start with the tutorial 2, question 7. So in this tutorial we are told that we have two gun pellets. Gun pellet A fired upwards simultaneously with pellet gun B, which was fired downwards from the cliff hill. So let's assume that this level, that is where our cliff is, so which I've represented with the dashed line. We assume that's our cliff. Okay, so the pellets are identical pellets and the firing is happening at the same time. That is why it is simultaneous. So which means we are firing at the same time. From which point are we firing? Okay, so this is the height of the cliff, which I have put here and represented with h meters. Okay, which is the same height from the right hand side of the cliff, which is also h meters. Okay, so pellet gun A is fired upwards. So from these two graphs you can see that from initial velocity is 30 meters per second. So we are firing it upwards and then this pellet returns down until it reaches the same level as it was fired from, okay, whereby the change in x is now 0 here. The change in y will be 0. So it will be fired from initial here, it goes up, it reaches the terminal velocity where the final velocity here, the terminal velocity is 0. It's no longer going upwards, and then the pellet goes down until it reaches the same initial point as it was fired upwards. So at this point, we know that the velocity at this point is the same as the velocity here, initial. But the only difference that is now in the negative direction because it's going upward, it's going downwards. So here the velocity was 30 meters per second, initially fired upwards, taking up as positive and downwards as negative. So it's just indication of the direction. Remember, velocity is a scalar quantity. It has a magnitude and the direction is downwards. Positive in front of the 30 indicate going upwards. Okay, so when this pellet A reaches this point, it's now the same with just firing the pellet gun B downwards with the same initial velocity of 30 meters per second. So this negative is indicating that we are firing downwards. Okay, so when down is positive, upwards, when down is negative, upwards is positive. That is the assumption we took in solving this problem. So from here, that is the cliff edge, the edge of the cliff. This is the ground. Okay, they reach the ground. So you can notice that this graph from here to there is the same as the graph from here to there. So the only difference is that this gun pellet A was fired upwards. So pellet B will reach the ground faster. Why? Because it was just fired downwards. Yet pellet A will have to take some time to go up and then it return to the same point. So basically this is the delay in time. If you can find the time taken for this pellet A to go upwards and return to the same initial point, then we can get the time for here. Then that's very sure, we are very sure that we are. Okay, so this is our ground, like as indicated. Then we are fired, it's being fired downwards. It's now dropping now with the initial velocity of negative 30. Okay, like I explained. So just take into account that when you fire it upwards with the 30 meters per second velocity, even the return at the same point is going to be negative 30 meters per second, but in the negative direction. So for pellet B, for the gun pellet B, it just started with negative 30, which means it's 30 meters per second downwards. Okay, so the time taken from here to there is the same as the time taken from there to there. So the only delay is the time taken for the pellet to reach the same position as it was thrown, the same level as it was thrown. Once we get this time taken for this trajectory from initial up to this final, then that is our delay in time, because everything downwards is the same. That is their approach of solving this problem. Okay, so we don't need to find the value of the height, we don't need to find what is the value of the height, we don't need to know what is the final velocity it hits the ground, we don't need to know what is the final velocity of the pellet B when it hits the ground. What we just want to know is the lagging in time. This is the lagging. So pellet A is lagging, is behind because it had to go up and down. Yet this one was just going down. So we are finding this time lagging, the lagging in time, then that will be our answer. So we are going to see how we are going to approach, then we can get the lagging in time.